Let's learn more about forces. The first force we're going to look at is called the normal force. We will start by reviewing Newton's third law. For every action, there is an equal and opposite reaction. So let's look at the example of a box resting on a table. We know that the box is being pulled down by gravity, so it pushes on the table with the force of gravity. Newton's third law tells us the table has to push back on the box with an equal and opposite force, and this force is called the normal force. The normal force is the force exerted on an object by the surface. The normal force is always perpendicular to the surface since it is provided by the surface. So on an inclined surface, it would look a little bit different than it does above. Notice the weight is still directly down, but the normal force is now at an angle because it has to be perpendicular to the surface, since it is provided by the surface. Now let's take a look at terminal velocity. A quick review. When the net force equals 0, the acceleration is equal to 0. If the acceleration is equal to 0, the object is either at rest or moving at a constant velocity. When this is applied to an object falling through a fluid, specifically air, we get the following diagrams. Make sure you are writing these notes on your diagram and in your composition book. As the object begins to fall through the air resistance will act on the object, creating a drag force in the opposite direction of the motion of the object. The longer the object falls, the more air resistance there will be as the object gains velocity. Eventually, the amount of drag force will be equal to the weight of the object. When this happens, the object has reached terminal velocity. Let's examine terminal velocity a little more closely. When an object reaches terminal velocity, the net force acting on the object is now 0 because the drag force and the weight are equal but in opposite directions. If the net force is 0, then the acceleration on the object is 0. Therefore, the object moves with a constant velocity, and this is called terminal velocity. We can sum this up by saying that terminal velocity occurs when the force of fluid friction is equal and opposite to the force of gravity. When an object reaches terminal velocity, the net force equals 0, so the object no longer accelerates. It falls at a constant velocity, which we call the terminal velocity.